Hello everyone, welcome once again to our lecture series of Introduction to Food Chemistry. And in this class, we are going to discuss the dispersed systems in foods. We are going to have two sessions for this. One, we shall understand the various dispersed systems in foods. And then two, we shall now understand a few of the other aspects that we shall not have looked at in part one. So what are dispersed systems in foods? Dispersed systems were introduced by a scientist called Thomas Graham that studied diffusion. And these dispersed systems are fundamental to the structure, the texture, and stability of many food products. They consist of one substance, that's the dispersed phase, distributed throughout another, and that other is the continuous phase, with the two phases typically being immiscible. Immiscible, we mean they cannot mix. They are incompatible. These systems are categorized based on the physical states of their phases and the size of the dispersed particles. These dispersed systems can be differentiated between two. One, we have the crystalloids, which pass through membranes, for example, sugar and salt. We also have the colloids that do not pass through membranes, for example, gelatin and glue. And we have found out that all these substances can form colloids if they are finally subdivided. Colloids in foods. Mr. Thomas Graham distinguished crystalloids from colloids. And by this distinction, we say that colloids consist of particles of colloidal size 1 to 1000 nanometers dispersed in a medium. Any substance can form a colloid if subdivided finely enough. We have three types of colloids. We have the true solutions, the colloidal solution, and the suspension. You find that the true solution is more compacted compared to the colloidal solution, and the suspension is sparsely distributed. Those are the types of dispersed systems. We have the true solutions, the colloidal solutions, and the suspensions. And we have said already that they differ by particle size. Colloids are intermediate. They are larger than the true solutions, but they are smaller than suspensions. A colloidal dispersion is equal to a dispersed phase plus a dispersion medium. Types of colloidal systems. These ones can be classified by the dispersed phase and the dispersion medium. And the examples here include the form, that is gas in liquid, and then emulsion. An emulsion is a liquid in a liquid, and then we have what we call a solid sol. This is a solid in a solid. These show various combinations. For example, the gas in solid, liquid in gas, with food examples. For example, whipped cream can be categorized in form, and then milk is an emulsion. Butter and cheese fall under solid emulsions. Sols are solid in liquid colloidal systems. And we have two types of salts. We have the lyophilic salts, which are the solvent loving, for example, starch dispersions in water. Then we have the lyophobic salts. These are solvent hating. For example, we have the gold salts. Lyophilic salts are more stable due to hydration bonding. Gels. These are liquid in solid colloids. We have examples and types of gels. We have the elastic gels. These ones deform and reform. For example, gelatin and starch gels. We have the non-elastic gels, which are rigid and do not recover. For example, silica gel. We also have the plastic gels. These ones have a brittle network from crystal formation. Caseinate gels. These can be found in milk as casein micelles. Gelatin forms elastic gels via long, flexible molecules and permanent crosslinks. Emulsions, we have the liquid colloidal systems. And here we have majorly the oil in water, and then we have the water in oil types. These require emulsifying agents, for example, soap, and synthetic detergents to stabilize. What are some of the roles of emulsions or emulsifiers? Emulsifiers reduce surface tension and prevent droplet merging. They also help to keep oil droplets suspended in water and vice versa. For example, we can suspend soap in oil-water emulsions, which holds droplets apart. Thank you. This is the first part of our lecture.